Okay, good afternoon all. In last lecture, we have covered Maxwell's LC bridge. Then we have also covered sharing bridge. Then again we have covered which one? Vein bridge, right? Then before that lecture, we have covered inductance comparison bridge, that is Maxwell's bridge. Then I told you to derive expression for de Sauty's bridge. Okay, and you have not given your answers for this one, and this is not good. If one task is given to you, then you should be ready with that one. Okay, but you have not solved this one. So only two bridge are remain to explain. One is de Sauty's bridge and other is Hayes bridge. Okay. After explaining these two bridge, we are going to solve numericals based on all the bridge. Okay, we have solved numerical of Wheatstone bridge only. Okay. After completing one, we will solve numericals based on all this bridge. So let's start. Okay, now tell me what is Z1? Niranjan? Z1, what is value of Z1? Z1, the arm 1 is purely resistive, so Z1 will be
R1.
R1. Z2, again the arm is purely resistive, so Z2 will be what?
R2.
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 Z3, in Z3 what we have? R3 is in series with C3.
C3.
Okay, R3 series in C3. So R3, if capacitor is in series, what should we write here? Minus J divided by omega C3, right? And Z4, again here Rx is in series with Cx, okay? So I will correct it. Instead of Z4, I will write here Zx. Okay, so what is value of Zx? Rx is in series, means what? Rx minus J divided by omega Cx. Okay, so this is our equation number 1. Okay, this is balanced condition, and this is our equation number 2. So put all the values of equation 2 in equation 1. So what we get here? Z1 is R1, Zx is Rx minus J divided by omega Cx is equal to R2, and Z3 is what? R3 minus J omega divided by J divided by omega C3, right? So solve this equation. R1 Rx minus R1 J divided by omega Cx is equal to R2 R3 minus J minus R2 J divided by omega C3. So we will separate out real and imaginary term. Okay, this part is real one and this part is imaginary one. Okay, so we will separate out real and imaginary part. So what we get here? R1 Rx is equal to R2 R3. Okay, so Rx is equal to what? R2 R3 divided by R1. This is our equation number 3. And imaginary part is what? R1 J omega Cx is equal to R2 J omega C3, right? So this J will get cancelled. This J and omega term will get cancelled. And what remains here? Cx is equal to what? R3, not R3. What will come here? C3, right? So C3 R1 divided by R2, right? So this is our equation for unknown capacitor Cx. So this is our equation number 4. Okay, so this is what de Sauty's bridge, or it is also called as capacitance comparison bridge. Okay, arm 1 and arm 2 are resistive, and the standard capacitor C3 is in series with R3 in third arm. Okay, and Cx is what? Unknown capacitor, and Rx is small leakage resistance. So this Rx and Cx are what? Unknown resistor and unknown capacitor. So in this case, an unknown capacitor is compared with standard capacitor, and the value of the unknown capacitor is calculated. Okay, so this bridge is called as what? Capacitance comparison bridge, as well as de Sauty's bridge. Okay, so this is explanation for de Sauty's bridge. Next is Hayes bridge. Okay, next bridge is Hayes bridge. So draw diagram with me. Don't waste your time. So in second arm we have standard resistor and standard capacitor C1, R1. Here we have R2. This is first arm. And in third arm we have resistor R3. And in fourth arm we have resistor is in series with inductor. Okay, so this is Rx and this is Lx. We are going to apply AC voltage to bridge and the detector in between these two terminals. So this is Hayes bridge. Okay, so here we have R1 in series with capacitor C1. Okay, R1 is in series with C1. In Maxwell's bridge, what was configuration? R1 was in parallel with C1. Okay, R1 and C1 parallel hote. Here what we have, R1 and C1 are in series. Okay, so this bridge is more convenient to measure high quality factor. Okay, this bridge is used to measure high quality factor. This is advantage of Hayes bridge. Okay, so we can measure quality factor greater than 10 also with the help of Hayes bridge. So whenever the quality factor is high, then instead of Maxwell's bridge, Hayes bridge is preferred. Okay, so let's start derivation for this one. First we'll write balanced condition. At balance, what we have? Z1, Zx is equal to Z2, Z3. This is our equation number 1. Okay. Then tell me Z1 is in series. Okay, in de Sauty bridge we have solved this. If capacitor is in series, then what we'll write? Yes, who is going to give answer?
R1
Z1
minus
R1 minus J divided by omega
omega
C1. Okay, Z2 is purely resistive, so it will be R2. Z3 again it is purely resistive, so it is R3. And what about Z4? Not Z4, not it is ZX. What about ZX? Again, here what we have? Resistor is in series with inductor. So inductor जर series मध्ये असेल तर काय आपण घेतो? Rx plus j omega Lx. So this is our equation 2. So place all the values of equation 2 in equation 1. Okay. So what we'll have here? R1 minus j divided by omega C1 into Zx. Zx is what? Rx plus j omega Lx is equal to R2 R3. Okay. So multiply this one. So R1 Rx plus this j into j, it become minus 1. So this term becomes what? Plus 1. So here we get Lx divided by C1. Omega omega will get cancelled. J into j is what? Minus 1. And here again we have minus sign. So minus 1 into minus 1, it become plus 1. Okay. So j into j is what? 1, minus 1. Okay. So again multiply this term R1 to this one. So what we get here? J Rx divided by omega C1 plus J omega R1 Lx is equal to R2 R3. Okay. Then again equating real and imaginary terms. What we'll have here? Saurabh? Yes, Saurabh, is there any problem? Okay, so separate real and imaginary terms. So R1 Rx plus Lx divided by C1 is equal to R2 R3. Here we have two terms in LHS. Okay, this one and this one. These two terms are real one and this one of RHS. Okay, so this is what real term, and what we have imaginary term Rx divided by omega C1 is equal to omega R1 Lx. Okay. So here we are going to solve equation for Rx. Okay. So we can rewrite this equation like Rx is equal to what? Omega square Lx C1 R1. Right. So this is our equation for Rx. Okay. This is not still final equation. Again, we are going to solve the equation for Lx. Okay, this is our equation 3. This is equation 4. Okay, up to this, have you completed up to this point? Yes, everyone?
Yes, ma'am.
Okay. Okay, so what we get at the gain equation for Rx is what? Omega square Lx C1 R1, and what we get here? R1 Rx plus Lx divided by C1 is equal to R2 R3, right? This was our equation 4 and this is our equation 3, right? मी पुन्हा लिहिलेलं आहे same equation 3 and 4. Okay, so what we are going to do, we are going to place value of this equation 4 in equation 3. Okay, so put the value of Rx in equation 3. So what we get here, R1 into bracket omega square Lx C1 R1 plus Lx divided by C1 is equal to R2 R3. Okay, so solve the equation. Okay, so this is what R1 square, okay, omega square R1 square C1 Lx is equal to, sorry, not equal to, plus Lx divided by C1 is equal to R2 R3. Okay, what we are going to do here? We are going to multiply both sides by C1. Okay, so what we get here? Omega square R1 square C1 square Lx plus Lx is equal to R2 R3 C1, right? So we can take Lx common from this equation. Okay, Lx is here and Lx is here. So take Lx common from this term. So what we get here? 1 plus omega square R1 square C1 square is equal to R2 R3 C1, right? So Lx is what? Lx is R2 R3 C1 divide by 1 plus omega square R1 square plus, sorry, not plus, into C1 square. Okay, so this is our final equation for Lx. Okay, so you can mark it as equation number 5. Then again, what we have equation for Lx, again you can find out Rx by placing value of Lx in equation 4. Okay, इथं आपल्याला unknown resistance मिळालेला. Okay, Rx is in terms of unknown inductance. So what we are going to do, put equation 5 in equation 4. Okay, so Rx is equal to omega square C1 square R1 R2 and R3. Okay, C1 is present in Rx, so C1 square. Okay, rest of the terms will remain as it is and divide by 1 plus omega square R1 square and C1 square, right? So here we get final equation for Rx. Okay, why this equation is not final equation? Because this equation includes Lx and Lx is unknown to us. Okay, so Rx should be in this way that we can calculate Rx with the help of standard resistor and standard capacitor. Okay, so this equation doesn't include unknown inductance. Similarly, Lx, okay, Lx also in this equation number 3, there is term Rx, okay, which is again unknown. So we could not find out Lx from this equation. So we have solved this equation to get Lx in terms of standard or known values of resistors and capacitors. Okay, so this equation number 5, it doesn't contains what? Unknown resistance, and this is what equation number 6, which again do not contains unknown inductance. So these two equations are final equations for Lx and Rx. Okay, so there is one term appears in equation of Lx and Rx, omega. Okay, omega is there, which indicates that the bridge is sensitive for frequency. Okay, bridge is sensitive for frequency. Why? Because presence of omega term in equation of Lx and Rx. Okay, so as we said, what the bridge is used to measure quality factor. Okay, so Q is given by one divided by omega square R1 square C1 square. Okay, so again we can rewrite the equation in terms of Q. Okay, so Lx will be what? R2 R3 C1 divided by 1 plus 1 divided by Q square. Okay, so this is what equation of Lx in terms of quality factor. Okay, so this is about what? Hayes bridge. लक्षात आलेला आहे? Is there any doubt? Okay, if you got all the points, then we'll move forward to solve numericals based on this bridge. Okay, because after 4, I have initiated one test. Okay, you can see on your Moodle account. There is one test, and in that there is only one question for 5 marks. Okay, one numerical for bridge is given. You have to solve that numerical and you have to upload the file for that numerical. Okay, today there is test which is based on numerical of the bridge. Okay, so we'll start numerical. Before going towards numerical, we'll just revise all the points of bridge. Okay, so tell me what we have studied first. We have studied Wheatstone bridge. Okay, draw circuit diagram for bridge. Okay, and write balanced equation or equation for unknown resistance. What is this? R1 Rx is equal to R2 R3, means Rx is what? R2 R3 divided by R1. Okay, to Wheatstone bridge we always DC supply. Okay, we always connect DC supply to Wheatstone bridge. Then after Wheatstone bridge, what we have studied? We have studied Kelvin's bridge. Okay, before in Kelvin's bridge, again we have studied some important points of Wheatstone bridge. What are that points? We have studied the two conditions for bridge: when bridge is balanced, when bridge is unbalanced. So this is equation when bridge is balanced. Okay, when bridge is unbalanced. Okay, when bridge is unbalanced. In that case, what we have calculated E or VAB is equal to what? E into bracket R3 divided by 1 plus R3 minus Rx divided by 1 plus R2 plus Rx. Right? Then this is what? Thevenin's voltage PTH, or we have also called it as VAB. Okay. RTH, Thevenin's equivalent resistor, it is calculated by equation R1 R3 divided by R1 plus R3 plus R2 R4 divided by R2 plus R4. Right? Then in next case, what we have studied? Bridge is slightly unbalanced. Slightly unbalanced. Okay. So in that case, what we have assumed that R1 is equal to R2 is equal to R3 and R4 is equal to R plus delta R. R4 is equal to R plus delta R, right? Then we got Thevenin's voltage ETH or VTH is equal to E delta R divided by 4R. Okay. And RTH is same as that of R. So these points we have discussed in Wheatstone bridge. Then in Kelvin's bridge, what we have discussed? We have discussed that it is used for low resistance measurement. Okay, Kelvin's bridge is used to measure low resistance. Okay. So draw circuit diagram. Okay. Again, we applied DC voltage to the Kelvin bridge. Okay. What is balanced condition for Kelvin bridge? Yes. For Kelvin bridge, we have studied that R1, R2 is equal to A divided by B, and unknown resistance is equal to R1, R3 divided by R2. Okay. If this R1 divided by R2 is equal to A divided by B, then we get this equation for unknown resistance. Okay. Then we have studied AC bridge. Okay. In AC bridge, first bridge which we have discussed. Which bridge we have discussed first? Inductance bridge. Okay, inductance comparison bridge or Maxwell's inductance bridge. Okay, so again draw circuit diagram. This bridge is AC bridge, so always apply AC supply to the bridge. Okay, Then what we find? Lx is equal to R2 into L3 divided by R1, and Rx is equal to R2 R3 divided by R1. So these two equations we got for what? Inductance bridge, which is also called as Maxwell's inductance bridge. Okay. Then just after that, we have discussed which bridge? Yes, just tell me. Sharing bridge. Okay, just we'll go with sharing bridge. Okay, sharing bridge. What we have discussed in this bridge? Capacitor is in parallel with resistor in first arm. In third arm again there is capacitor. So don't forget to draw circuit diagram. Okay. Then again we apply AC supply. Then what we found that we calculated unknown capacitance with the help of equation R1 divided by R2 multiplied by C3, and unknown resistance Rx is calculated by equation R2 C1 divided by C3. Okay. Again, we have calculated dissipation factor D is equal to 1 divided by Q, okay, which is equal to omega Cx Rx. So these are some points for sharing bridge. Okay. Then we have discussed which bridge? Maxwell's LC bridge. Maxwell's LC bridge. Okay. In Maxwell's LC bridge, capacitor is in parallel with resistor and inductor is in series with resistor in fourth arm. Okay. So again we got here equation for unknown resistance R2 R3 divided by R1, and unknown inductor is equal to C1 R2 R3. Again this bridge is used to measure low quality factor, which is given by omega Lx divided by Rx. Okay. Or we can write it as omega R1 C1. So this is equation for Maxwell's LC bridge. Then today we have discussed which bridge? De-Sauty bridge. De-Sauty bridge, which is also called as capacitance comparison bridge. Okay. So here there is in two arms, capacitor is in series with resistor. So we got here equation for unknown resistor as Rx is equal to R2 R3 divided by R1, and for unknown capacitor Cx is equal to R1 C3 divided by R2. Okay. So these all bridges are AC bridge. So apply AC supply, draw circuit diagram, AC voltage is required. Okay. So this is capacitance comparison or de-Sauty bridge. Then we have discussed Hayes bridge. Okay. From Hayes bridge, what we get? Again, draw circuit diagram. Then AC voltage is required here. Rx is equal to omega square C1 square R1 R2 R3 divided by 1 plus omega square R1 square C1 square. Okay, and Lx is what? Lx is R2 R3 C1 divided by 1 plus omega square R1 square C1 square. Okay, so this is summary of 6th chapter. ठीक आहे, पूर्ण आपण समरी जी आहे ती मी इथं लिहिलेली आहे. ठीक आहे, तुम्हाला अशी समरी बनवून ठेवायची आहे. बुक मध्ये सर्किट डायग्राम ड्रॉ करायची आहे आणि इक्वेशन्स खाली फक्त लिहायचे. ओके, सो विल सॉल्व न्यूमरिकल्स बेस्ड ऑन दिस चॅप्टर फर्स्ट. Okay, so if our lecture ends here, again rejoin the lecture with same link.